बिस्मिल्लाहिर्रहमानिर्रहीम सल्लल्लाहु अलैहि वसल्लम अल्लाहुम्मा रब्बि ज़िदनी इल्मा सल्लल्लाहु अलैहि वसल्लम आमीन अल्हम्दुलिल्लाहि रब्बिल आलमीन. The topic of this lecture is important questions of iterations. For this lecture, I am using the work of one of my best student, Miss Sharika Batul, of the class 2020, the Lyceum. An important advice for me and for everyone: we should be selfless. Before starting the important questions, I would like to uh, give you a short summary regarding the iteration concepts. Well, in iterations, there are 7 or 10 types of questions. Usually, we get those types of questions. So, this is the type 1. Show by sketch that there is only one solution to the equation. To show this, we need to sketch sec x for this domain separately, and then 3 minus half x squared separately. And then, according to this sketch, with respect to this sketch, we can say that there is only one point of solution. There is one intersection, so one solution. So whenever they give this type of question, show by sketch that there is only one solution, you just need to sketch both the graphs separately for the given domain, if domain is given. Then you just need to say, since there is one point of intersection, so there is only one solution. This is the type 1 question. And this question usually has 2 marks. This is the type 2 question. Show by calculation that the root of f of x lies between a and b. For that, you just need to find f of a and then f of b, and you just need to observe their signs. What if f of a is positive and f of b is negative? Then you will see, since f of a changes its sign from positive to negative, therefore the root of f of x will lie between this interval. This is an example of this. This is the f of x, and we have to show that the root lies between these two. So first we will work for f of 0.5 and then 0.8. Since this is positive and this is negative, hence shown that the root of f of x lies between these values of x. Make sure your calculator should be in radian mode. I'm sorry. I have discussed these concepts in detail in my lecture 1. This is type 3 question. They will give you the iterative formula and they will ask you find the root of the equation. Well, they will give you, usually they give, the examiner gives the initial value. If the initial value is not given, then this can be considered as the initial value. You can also take this as initial value, you have choice, but it's better to take this value as the initial value. And you all know how to do the iteration. You just need to start with x1, 0.5, you need to substitute 0.5 here, and then you will get x2. You have to repeat the process unless you get a repeated number. This is the repeated number, so your answer is 0.62. You need to substitute this equation in your calculator, and then you need to press calculation button. The calculator will ask you the value of x. You need to substitute 0.5, put 0.5 in your calculator, press equal, and get this answer. And then for x3, you need to put this number in your calculator. Press calculation button, substitute 0.6747, and press equal. Calculator will give you this answer. In the same way, you can get all the numbers. The method is very simple. First, substitute this equation in your calculator carefully, and then press calculation button. Then calculator will ask you the value of x. Then substitute or put 0.5 in your calculator and press equal. Calculator will give you this number. In the same way, put this number in your calculator. Press calculation button, put this number, and then press equal. Calculator will give you this number. And in the same way, you can get all the numbers. You can either get a repeated number or a repeated pair. This means a repeated pair. So when you get a pair, then just take the average of that number, that pair, to get the answer. Type 4 question. In type 4 question, they will give you two different equations and they will ask you convert the second equation into first equation. Like this. This equation is given. Show that the root of this equation also satisfies this equation. That means you need to convert this equation into this form. For details, you must watch lecture 1 on this topic. You just need to remove all n plus 1 and n by x because it says the equation has converged. So replace all n plus 1 and n by x. Use this. Xn plus 1 is equal to xn is equal to x. We use this when the formula is converged. So by using this into this equation, we'll get this equation. Now you just need to convert this equation into this form. Bring this cos here, take the reciprocal of this cos because we need sec, and then by breaking the LCM of the right side, we have shown this. Type 5 question. State an equation satisfied by alpha. Alpha means the root of the equation. Like xn plus 1 will be alpha. And hence find the exact value of alpha. Iterative formula will be given. By applying this equation onto iterative formula, we'll get this equation. Now you just need to make alpha subject. And this is the exact value of alpha. Type 6. Find two consecutive integers between which the root of the equation lies. You just need to start with the positive integers. First try the positive integers. Use 1, 2, 3, 4, 5. Suppose this equation as f of x, and then check f of x, the sign of f of x on these numbers. As soon as f of x will change its sign, stop the process, stop the trial and error method, and state the integers. Since f of 3 is negative and f of 4 is positive, therefore the root of f of x lies between these two integers. This is the trial and error method, and try to use the positive integers first. And this is the type 7 question, the circular measure based question. For this type, you must know the formulas of circular measure, these formulas, the formulas of triangle, right angle triangle, these things. And this is the example of type 7 question. This diagram is given and the information is given. The area of this segment is a quarter of the area of semicircle. So area of segment means sector minus triangle, and semicircle means pi r square upon 2, and quarter means 1 upon 4. Sector means half r square pi minus x, and triangle means half r square sine pi minus x. Sine pi minus x is sine x because this sign is in second quadrant. By simplifying this equation, you can get the answer. Let's start the solutions of important questions. I'm sorry. This sequence, question number 1, the sequence of values given by iterative formula. This is the iterative formula. This formula is here. With initial value 3, converge to alpha. Use this iterative formula to find alpha, correct to 2 decimal places, giving the result of each iteration to 4 decimal places. This is so simple. You need to substitute this equation in your calculator and then use calculation button. When you will substitute this equation in your calculator, and then when you will press this button, calculator will ask you the value of x. Substitute 3. Put 3 in your calculator, press equal, calculator will give you this number. Then again press calculation button, put this value in your calculator and press equal, calculator will give you this number. In the same way, you can get this number. As soon as you get a repeated number, stop the process and write your answer. So the answer is 2.78. Part 2. State an equation satisfied by alpha and hence find exact value of alpha. This is the type 5 question. So since it's mentioned this equation has converged to alpha, therefore converge means xn plus 1 is equal to xn is equal to alpha. So by applying this equation onto this iterative formula, we have this equation. Now we just need to make alpha subject. First you need to take the LCM and then you need to make alpha subject. By cross multiplication we have 4 alpha 4. By bringing this 3 alpha 4 on the left hand side we have alpha 4. This is the equation of alpha and this is the exact value of alpha. These two are the required answers of this part 2. Question number 2. The equation x cube minus 8x minus 13 has one real root. Let's suppose this equation is f of x. You need to suppose this as f of x first. And then you need to, the part 1 is find the two consecutive integers between which the root lies. For that, you need to try the numbers. This is the type 6 question, I think. You need to use trial and error method. First, start with 1. Try 1. Then 2, 3, 4, 5. You have to repeat the process unless f of x will change its sign. As soon as f of x will start changing its sign, stop the process and get the required integers. The required integers are 3 and 4 because f of 3 is negative and f of 4 is positive. That means the root of f of x lies between these two integers. So you have to use trial and error method for this type of question. Now use the iterative formula. This formula is here. To determine this root, correct to 2 decimal places. Give the result of each iteration to 4 decimal places. This means the initial value will be 3. You have option. You can take this as initial value or this as initial value. It's better to take this as initial value. So first put this equation in your calculator and then press calculation button and then put 3 in your calculator and then press equal. So calculator will give you this number. Then press calculation button again and then put this number and press equal. Calculator will give you this number. You have to repeat the process unless you get a repeated number. This is the repeated number. So stop your process and then write your answer up to 2 decimal places because it is required. Question number 3. The first part is type 7 question. This diagram is given and this information is given. The area of the shaded segment, this area, is a quarter of the area of the semicircle. So this area is the area of sector minus area of triangle. Sector minus triangle. And this is 1/4 of the area of the semicircle. So quarter means 1/4 and area of semicircle is pi r square upon 2. Area of sector, as you know, half r square pi minus x. This angle is pi minus x. And area of triangle is half r square sine pi minus x. So by cancelling half r square on both sides, we have pi minus x, sine pi minus x, pi by 4. Sine pi minus x is sine x because it is in second quadrant. In second quadrant, sine is positive, so it will become sine x. Hence, this is the required answer. Number 2. this equation has one root. Verify by calculation that the root lies between these two numbers. This is so simple. You just need to equate this equation first to 0. First equate this equation to 0 in any way. I mean, you can bring sign on left side or you can bring x on right side. You have option. So first equate this equation to 0. Then suppose this equation is f of x, and then use 1.3 and 1.5 in radian mode. I'm sorry. One answer must be negative and the other answer must be positive. In any way, you can get this positive and this negative, or this negative or this positive. Right now, this answer is negative and this is positive. Therefore, root of f of x lies between these two numbers. Use this iterative formula to find the root, and the answer should be 2 decimal places and each iteration up to 4 decimal. So first you need to substitute this equation in your calculator, then press calculation button. Calculator will ask you the value of x. You need to substitute 1.3 and then press equal. Calculator will give you this number. And you just need to repeat the process unless you get a repeated number. This is the repeated number, so this will be the answer. Initial value was not given, so you can suppose this as initial value. This is question number 4. This is the minimum point. You all know how to get the x coordinate of minimum point. At minimum point, gradient is 0. Show that the x coordinate of m satisfies this equation. That means you need to differentiate this equation and equate the gradient to 0. So by differentiating this equation, by using u upon v rule, we have this. By equating gradient to 0, we can get this equation. We applied u upon v rule over here. Number 2, iterative formula is given and they ask find the root. Initial value is not given, but see, this m is close to pi. You have two numbers, pi and 2 pi. So since this m is close to pi, this x coordinate is close to pi, therefore you can suppose x1 as pi. You can also suppose x1 as 2 pi, it's your choice, but since m is close to pi, so this will be x1. So x1 is pi, and this is the answer, 4.49. This is the way to get the value of x1. When diagram is given and x1 is missing, you just need to estimate x1 from the diagram. This is as x1. Question number 5. The curve has one stationary point. For that, you just need to differentiate this equation by using u upon v rule. We have this. Equate gradient to 0 and then get the answer. Show that the root lies of this equation between 3 and 4. First equate this equation to 0. When you will equate this equation to 0, you will get this thing. Now suppose this as f of x and then check 3 and 4. This is negative and this is positive, hence shown. This is the iterative formula. x1 is 3. Do the iteration with x1 3. This is the answer. Question number 6. By sketching suitable graphs, show that this equation has just one root for this domain. So first we need to sketch cot x and then 4x square minus 1. This 4x square is happy phase. And you have to sketch this from minus 1. You can make the table if you want. So this is 4x square minus 1, happy phase. This is the complete curve. But since we have this domain, so we have to sketch according to given domain. So this is 4x square minus 1 and this is the cot x. And there is just one point of intersection. That means there is just one root. Verify by calculation that this root lies between these two numbers. You know how to solve this part. You just need to equate this equation first to 0 and then you need to substitute 0.6 and 0.1. This is the way of equating this equation to 0. First get the reciprocal of this, tan x 1 upon this, bring this thing on left side. You can also bring tan x on the right hand side. This is your choice. This is f of x. So f of 0.6 is negative and this is positive, hence root lies between these two numbers. Now this is the iterative formula. We have x1 0.6. So by using x1 as 0.6, we can get the answer. This is the answer. Substitute this equation in your calculator carefully. And you all know how to do the iteration. Press calculation button and then put 0.6 and press equal. Calculator will give you this answer. This is the integration in iteration. ln x over x square. This equation is here. And the question is, this is given and we have to show this thing. This is by parts. So by using integration by parts, we can integrate this thing. U is ln x, dv is x power minus 2 dx. We always differentiate u to get du and we always integrate dv to get v. And this is the by parts formula. You all know how to do by parts. I'm not going to explain this thing. You just need to simplify this and this is the answer. You should be good at integration to handle questions of these types. I'm more focusing on iteration. Use an iterative formula. You can make this as iterative formula, convert this into iterative formula by writing n+1 here and n here. I explained this thing in detail in my first lecture, how to make the iterative formula. Use the initial value 4 and find the answer. You just need to write n+1 here and n here, because this equation has converged. And let the a1 is 4 is given. You don't need to suppose this because it's given. a1 is 4. Therefore, with 4 we can start the iteration, and these are the results. And this is the repeated number, I guess. Let me correct this. I think this is 19. You can check this later. I think this student has made a mistake. She wrongly wrote 2 here. It's 9, I guess. You can check this later. This is the type 7 question. Part 1 is of type 7. According to my notes, the diagram shows a circle, center O and radius 10. The chord AB divides the circle into 2 regions in the ratio 1:4. And the angle AOB is theta. Show that this thing. See, this is 1 and this is 4. This diagram is here. This segment is 1 and this is 4 in ratios. So this area, the area of minor segment, will be 1/5 area of the whole circle. So area of the minor segment is 1/5 area of the circle. Let me correct this. Circle, pi r square. This is not 2. One upon 5 pi r square. So this will be 2 pi by 5. And area of the segment is sector minus triangle. This sector minus this triangle. This is what we had to show. And how to get this length AB? You have options. Either you can use cosine rule, or either you can drop a perpendicular from 0 to chord AB, from this origin to this O to chord AB. This is OM. This is not 0, this is origin, I'm sorry. So AM, first get the length AM. by using sine in this triangle. So this is the length of AM and AB is twice of AM. So this is the another way of getting AB. So you have options, either use cosine rule or use sine in this triangle, because we need the length of AB in the next part. Well, you have to make this, you have to convert this into iterative formula and start the iteration with 2.1. So this is the iterative formula and the initial value is 2.1. This is the answer, 2.11, and the question is find the value of AB. You have option, either substitute theta here or here. Method 1 by using cosine rule, and this is the method 2. If you want to take the screenshot of this question, you can. I'm leaving question 9 because this is similar to question number 8. Now I'm going to discuss the important questions only. Question number 10. By sketching a suitable pair of graphs, show that this equation has just one solution in this interval. So you have to sketch cot x separately and 1 plus x squared. This is happy phase from 1. So this is here. This is the complete curve. But since we have to work according to this domain, so we have to sketch just this part. And this is the solution of these two curves, graphs. There is just one solution according to this sketch, hence shown. You all know how to verify this. You just need to equate this equation first to 0. First convert cot in the form of tan. Get the reciprocal of cot. This is tan and this is 1 upon 1 plus x squared. Suppose this as f of x and then substitute 0.5 and 0.8. This is negative, this is positive, hence shown. This is the iterative formula and we have to find the root with x1 0.5. So x1 is 0.5 and here is the repetition. This is the answer. Question number 11. This is an important question because it includes 4 steps. By sketching a suitable pair of graphs, show that this equation has one root in this interval. You all know how to sketch sec x. This is the graph of sec x and this is the sat phase. Sat phase. This should be like this. Sat phase from 3. Negative x square means sat phase and 3 means the turning point is at 0, 3. Hence shown there is just one point of intersection, so one solution in this domain. You all know how to verify this. You have to convert this equation into this form first. Equate this to 0. This is the f of x, equation of f of x. F of 1 is negative, this is positive, hence shown. The root lies between those two numbers. Now show that this root also satisfies this equation. I think this is step number maybe 6 or 7 in my notes. You have to convert this equation into this form. Show that this root means the root of equation 1, also satisfies this equation. That means convert this equation into this form. Means both equations are same. You just need to show this. So by bringing the cos here, we have cos x. And by taking the reciprocal of cos, we have sec x here. And this is the equation, required equation. This is what we had to show. And the last step is simple. You have to convert this into iterative formula. Initial value is not given, I guess. No, sorry. Initial value is this 1. It's given. So this is the iterative formula. Initial value is 1. This is the repetition. So this will be the answer up to 2 decimal places. If you want to take the screenshot of this question, you can. Question number 12, it involves integration. You all know by parts. This is by parts. So by using by parts, we have to show this. I'm leaving part 1. If you want to see the solution, you can, because I'm more interested in iteration. You all have done an integration, so you can manage this by parts thing easily. Part 2, use an iterative formula based on the equation in part 1 to find the value of alpha, initial value 6. So you have to convert this answer in the iterative formula first. Write n plus 1 here and n here. Now put this equation in your calculator, then press calculation button and put 6 in your calculator, press equal, calculator will give you this number and you know how to complete this. This is, I think, something wrong. Let me correct this. Maybe this number is, either this number is 63 or this is 63. Not sure. You can check this later. I'm writing this as 63. You can check this later. You can do this yourself. Question number 13. It is given that 2 tan 2x plus 5 tan square x is equal to 0. Denoting tan by t, form an equation in t and hence show that t is 0 or t this. Okay. So first we need to solve this equation. Tan 2x can be written as 2 tan x upon 1 minus tan square x. You can write this as 2 tan x. It's fine. Tan plus tan or 2 tan x means same thing. But it's better if you would write 2 tan x here. Well, by taking the LCM, we have this equation. And from this equation, you can take tan x common. So finally, we have tan x equals to 0 and this equals to this. Since we have to show cube root, so we need to make the tan cube x subject first. Replace this tan cube by t cube, this tan by t because it's given, and make this t subject by taking cube root on both sides. This is what we had to show. And the second part is very simple. We have this numbers 1.2 and 1.3. We just need to check the root lies between these two numbers. This is so simple. We need to equate this equation to 0. So by equating this equation to 0 first, we can check this. This is negative and this is positive. This is the form. Part 3, use the iterative formula, find the root. This is so simple. This is 1.2. So here is the repetition and this is the answer. And the last part is find the value of t. As you know, tan t is 1.276 and t is tan x. So this is x. We had to work according to this domain. I'm leaving this question 14 because this is similar to this question, question 8. You know how to show this. If you want to take the screenshot, you can. And second part is simple. We just need to use iterative formula to get the answer. This is the substitution and by parts question. Part 1. Use the substitution x is equal to u square, find this and then show this. So this is the substitution. We need this area and it's given the area is equal to 1. Y is equal to cos root x. This is the equation. So cos root x equals to 0. X is pi square upon 4. This is the area formula. X is u square. So under root x is this. This is the substitution and integration. I hope you can manage this yourself. You can take this screenshot if you want. Here you have to use by parts. This is the by parts. And this is what we had to show. This is the pi square upon 4. And then the next part is, this is the iterative formula. We need the root. P1 is 1. This is so simple. The first part of this question is find the exact value of the x coordinate of m. M is the maximum point. You need to differentiate this and equate the gradient to 0 for m, for the x coordinate of m. So this is the dy upon dx. By equating this dy upon dx to 0, we have got x 1 upon root 2. And this is the iterative formula. X1 is 2. And the question is, this is step number 5 in my notes. This formula is converged to alpha, state an equation satisfied by alpha, and hence show that alpha is the x coordinate of a point on the curve where y is 0.5. You just need to convert this equation into this form. Here is the solution of part 2. First, use this and convert this equation into this formula, into this form. By removing ln, we have e alpha square 4 plus 8 alpha square. We are trying to get this form. E minus half x square 1 plus 2x square under root. So we have this e alpha square. By taking square root on both sides, we have this. By taking the reciprocal of this e, we have this equation. By bringing this root here, we have this. This is y, so y is 0.5. This is what we had to show. Check this question again. Take this screenshot because this question is important. The part 2 is important. Part 3 is simple, it's iteration. I'm leaving part 3. Part 2 is very important. Try to convert this equation into this form. You need to bring y in this equation because you have to show y is 0.5. (17) is simple. This is alpha and this is beta, and the diagram shows the graph of this equation. And this is alpha and this is beta. Find the value of alpha. You all know when we have power 3 or power 4 equation, degree 3 or degree 4 equation, we find the first root by trial and error method of the equation. So we can find the root of this equation, the first root of this equation, by trial and error method. Since alpha is on left side of the origin on the y-axis, therefore the alpha must be negative. So we need to try -1 first. When we will try -1, we won't get 0. But when we will try -2, then we'll get 0. So alpha is -2. This is the way to get the first root of the higher power of equations, like power 3, power 4. Show that beta, this is part 2, satisfies this equation. Now we have to find the other roots of this polynomial. This is the linear root. Now this is the cubic root. So you all know when we have degree 3 or degree 4 equations, we always use a long division method. You have 3 options. Either use long division or synthetic division or comparing the coefficient. The comparing the coefficient method will be very difficult because we have 4 constants. So it will be very difficult to handle this. I always use long division. So by using long division, with this factor x plus 2 on this polynomial, we have this quotient. So by equating this quotient to 0, we can get the result. This is what we had to show. The last part is find the root. Use an iteration process based on the equation in part 2. Convert this in iterative formula, and then find beta. Find the beta value of beta, and iteration 4 decimal places should be. So by using x1 as minus 2, we have the value of beta 1.67. You can use alpha is 1, x1 is 1, because beta is close. Beta is between 1 and 2. So you should use x1 is 1 or 2 instead of using minus 2 here. Although you have got your answer, but what if you have used this x1, then you can get the answer in less iterations. So it's better when diagram is given, then estimate the value of x1 from diagram if x1 is not given. So x1 is 1, then x2, then x3. Maybe you would get your answer up to x5 something. This student used x1 minus 2. It's fine, but since beta lies between 1 and 2, so x1 should have been used as 1. This question 18 is simple. I'm interested in the second part of this question. State an equation satisfied by alpha and find the exact value of alpha. So you just need to convert this iterative formula into this equation by using this fact and make alpha subject. Alpha cube is 50, therefore alpha, this is the exact value of alpha. Always convert iterative formula into this equation by using this equation, and then try to make alpha subject. This is the equation of alpha, and this is the exact value of alpha. This question, part 1 I think is important. Show that alpha satisfies the equation, A or alpha. I think it's A. And it's given the tangents are parallel when x is A. So when tangents are parallel, then the gradient of these two curves will be equal at x is equal to A. So the gradient of this curve is this, and the gradient of this curve is this. At x is equal to A, these two will be equal, and hence shown. I'm leaving the later parts of this question because the later parts are simple. I will discuss this question in my next lecture. This is an important question. Inshallah, we'll discuss in lecture 3. This is all from this lecture. I will discuss this question in my next lecture and the leftover important question in my next lecture, inshallah. Allah Hafiz.